In the vast expanse of the universe, stars are the brilliant beacons of light that dot the night sky. These celestial objects have fascinated humanity for millennia, guiding explorers and inspiring poets. But the life of a star is a tale of transformation, driven by the fundamental forces of nature. Today, we will explore the remarkable life cycle of stars, from their birth in stellar nurseries to their eventual demise and the cosmic legacy they leave behind. To understand the life cycle of a star, we must journey to the very beginning, to the birth of a star. Stars are born in regions of space known as stellar nurseries or molecular clouds. These immense clouds of gas and dust are the birthplaces of stars, primarily composed of hydrogen, the most abundant element in the universe. Within these clouds, regions of higher density form due to gravitational instabilities. Over time, these dense regions collapse under their own gravity, pulling in surrounding gas and dust. As the material accumulates, it begins to heat up, forming a protostar, a young star in the making. During this phase, the core of the protostar continues to contract and heat up. When the temperature and pressure in the core reach a critical point, nuclear fusion ignites, converting hydrogen into helium. This marks the birth of a true star, shining brightly as it enters the next stage of its life. This newly formed star now joins the main sequence, a period of stability where it spends the majority of its life. During the main sequence, the star maintains a delicate balance between the outward pressure from nuclear fusion in its core and the inward pull of gravity. The duration of the main sequence phase depends on the star's mass. Massive stars, burning their fuel more rapidly, may only remain in this phase for a few million years. In contrast, smaller stars like our Sun can shine steadily for billions of years. The color and temperature of a main sequence star are determined by its mass. Massive stars are hot and blue, while smaller stars are cooler and red. Our Sun, a medium-sized star, shines with a yellow hue. As a star exhausts its hydrogen fuel, changes begin to occur. For medium-sized stars like the Sun, the core contracts and heats up, igniting helium fusion. The outer layers expand and cool, transforming the star into a red giant. In this phase, the star's size increases dramatically and its luminosity soars. The red giant phase is relatively short-lived compared to the main sequence, lasting only a few 100 million years. For the most massive stars, the process is even more dramatic. These stars become supergiants, undergoing a series of complex nuclear fusion reactions in their cores, creating heavier elements like carbon, oxygen, and iron. The final stages of a star's life depend on its mass. Medium-sized stars, like our Sun, shed their outer layers, creating beautiful planetary nebulae. The remaining core becomes a white dwarf, a dense, hot remnant that gradually cools over billions of years. In contrast, massive stars meet a more violent end. When fusion in the core produces iron, the star can no longer sustain nuclear reactions. The core collapses under gravity, triggering a catastrophic explosion known as a supernova. The supernova explosion disperses heavy elements into space, enriching the interstellar medium and seeding future generations of stars. Depending on the mass of the original star, the remnant core can become either a neutron star or, if sufficiently massive, a black hole. Neutron stars are incredibly dense, composed almost entirely of neutrons, with a mass greater than the Sun, but only about 20 kilometers in diameter. Black holes, on the other hand, are regions of space where gravity is so strong that not even light can escape. The life cycle of stars is a testament to the dynamic and ever-changing nature of the universe. Stars are not just solitary objects, they are part of a cosmic ecosystem. The elements forged in their cores, dispersed through supernovae, become the building blocks of planets, moons, and even life. The carbon in our cells, the oxygen we breathe, the calcium in our bones, all were created in the hearts of ancient stars. As we gaze up at the night sky, we are reminded of our connection to the cosmos and the enduring cycle of stellar life. The story of stars is the story of the universe itself, a cycle of creation, transformation, and renewal. And so, the next time you look up at the stars, remember that you are witnessing the ongoing saga of the cosmos, a tale as old as time and as infinite as the universe.